This is week 6, and we are in chapter 5, and we will talk for a long time about symbols, components, and some schematics for things we'll have in our HVAC system. This is third try. I've been counting. Yeah. Huh? What happened? You tell me what happened.
Very well.
He's lost.
When I said in front a little bit, I think you're missing a lot of material. There's an empty 2 seats here, please, because we went through it and we did even the homework. I mean the questions.
Oh yeah, I remember now. I really do remember now. Yeah, we went over the big questions right before we took
Yeah,
the test.
yeah. Okay. Can I start now? So components, symbols, and circuitry of air conditioning. We have a lot of components. It's good to know what are they called, what is each component function, and it requires some practice to know which component does what, and I will try to slowly introduce you to each one of them. We'll talk about loads and general purposes. What do they do? Each load, what does it do? What is its function? What's going on? What is happening? And what is the voltage? If you know something functions, you can know what does it do and if it's working or not. We'll give examples of loads in HVAC. Can you give me an example of a load? A fan, motor, resistance, heater. It's all loads. Loads consume. They consume power. What do they look like on paper? They're not going to put a picture of a motor. They're going to give you a symbol to make things a little bit easier. So, what are the symbols for those loads? We'll talk about relays and contactor. There's going to be a lot of relays and contactors, and I'll explain to you what they do, what is the difference between them, and switches. A lot of these things probably Bill talked about in his class. We'll keep iterating and reiterating what do they mean, what is each component function, and what do they look like. Other miscellaneous controls that you will have. We have a lot of control because we try to have some kind of systematic steps for the system to start up. Like for example, if you turn on your car keys, what happens first? Probably if you have a car in the 2000, the first thing that happens is you have to prime the engine, right? You have to bring fuel from the tank to the car. Probably you'll hear the gas pump turn on first, so you can prime the engine. As soon as you turn on the switch, what happens? The battery is engaged and the spark is coming to the starter motor, to turn on the motor, and we'll try for ignition. And that's when you crank up the engine. And once the engine is on, probably see a lot of controls happening. The first like few seconds, you see the temperature up, then it goes down, and probably the RPM is up, and it goes down, and until the car heats up. So there's a lot of sequence of events we want to have for the component to be running the way we intended it to be. We will also identify the difference between wiring diagrams used in the industry and what are their purposes. The book will be very handy. Who doesn't have the book yet? Please look through the book. There's a lot of useful information and it's very easy to read and to follow. So we will talk about the 3 kind of diagrams you'll have, which one to use for installation, which one is you can use for troubleshooting. Some of them are more elaborate than the others. Probably if you look at the machine, you'll see some kind of wiring, basic wiring diagram on the side. It tells you what is connected to what. If you go to the troubleshooting or maintenance diagram, you'll see a lot of information. Each size of components, how many amperes goes through it, and that will help you troubleshoot. Okay. So loads, as we said before, anything that consumes power, and they do useful work. They have to do something, otherwise they wouldn't be there. So a motor is a load, consumes a lot of power, and what does it do? It transforms electrical energy into what kind of energy?
Whatever you're starting.
Which is what kind of energy? Dynamic or mechanical? mechanical energy, so you're doing some movement using electrical power. So those are what motors. So motors, solenoid. What are solenoids? Solenoids are valves. We'll talk about solenoid plenty, but a solenoid is a valve that uses electromotive forces to close or open a valve. So a solenoid looks like has a stem in the middle, and it has the rule of the magnetic rule for a coil, and this thing goes inside the pipe and goes up and down, either by energizing or de-energizing. So solenoid is referred to any coil that opens and closes a valve. It could be something else. It could do something else. You can use solenoid as a sensor. For example, in your car, if you close the door halfway, what happens? And yeah, you hear a noise, and also probably the light will stay on, telling the door is not latched yet. So probably there's a solenoid over there. If you look closely, there's some button being pushed, and it does the same thing. What you're doing is you're pushing the rod in, and that will activate the solenoid, and it will tell the car that the door is closed. So you can use them solenoid as sensors, or you can use them as a function to open and close a valve. So would you think that the direction here of the current makes difference? Why not?
Because it's just doing one thing.
Yeah, but if you reverse it, it'll do the opposite, right?
Depends.
Depends. I like that. So it depends. Certain things will do something, some will not. If you have an AC solenoid, probably it will not make a difference if you reverse the polarity. If it's DC, probably it will change that. So those are solenoids. Resistance heaters, what do? So we said in the first week that when you run current through any material, it will have some heat generation, right? And that's why we have to choose the right gauge. If it's a small gauge and you run a lot of amps to it, it will overheat. So resistance has a relationship with temperature generation. Would you think that the material makes a difference? The material of which the resistance is made make a difference in the amount of heat? Yeah. So some material will heat up faster with more. What's happening with this? Will heat up faster.
Check the HDMI cables.
Yeah, that's what I'll do.
I'll pull this off. This thing is possessed. So,
Probably is, this building's old as shit.
some materials will have more heat when you run current through them. For example, if you look at the light bulb, what's the filament inside it? What is it made of? Some thin material that we're running a lot of current through. But if you look here at this little spiral thing, it's a filament, and it's not a solid wire, just small, very thin wire that's spiraled, and when you run 110 volts to it, it will heat up. It will heat to the point where it glows. And this is how we make light. So this material over there is overheating, and the overheating causes it to glow and make light. We can also put it up. And so this is resistance heating, and if you turn this light on for at least a minute, it will become very hot, right? It will be hot to the touch. So we can use the same kind of technology, same kind of idea of a spiral wire made out of material that has high resistance to generate heat, not light. We don't want it to glow. However, in some air conditioners that are equipped with a coil, probably you see like some old models, or a space heater, if you look, you'll see the wire actually glowing. It's kind of orange. Not to the point where it glows, but it's orange because it's getting really hot. Even your toaster oven, if you look inside while it's toasting, the heating element is almost orange or yellow. Also your stove gets yellow if it's really hot. So those are resistance heater. Any power consuming device, it's a load because it's going to take some wattage out of your circuit. So they are the most important part because we depend on them to operate the system. Otherwise, we have no use of electricity. But for your AC, if your compressor goes out, the whole thing is down. So you need all these components to work together to do a function. These are examples of some of the common loads you will see. This is an inducer fan, a cooling fan, and basically it's a motor. Some motors have variable speeds, and you'll see those in ductwork. You'll see them in an AC, and what they do is they move the air. They create pressure for the air, so the air will move from one place to another, and we'll have more convection. So it's going to be forced or natural convection? Forced, because we are using force to move the air from one place to another. Again, I go to the car example because everybody drives here. You have a car, you're familiar with the car. So what happens when you stop in a traffic light and your fan does not come up? Your temperature will go up. When you move in the highway, probably the fan will shut off because there's a lot of airflow. You stop and the fan have to kick in to induce natural convection.
Remember back in the days, you had to press on the gas.
Yeah,
to
yeah.
keep the car going?
Yeah, keep it going, and otherwise it will heat up. And sometimes you have to increase the radiator size. Sometimes you have to add a modification for electric fan because the engine is idling. And actually, I used to have a car like that. I'll have a fan with a switch, so when I stop, I turn on the switch so it will never overheat. Otherwise, you have to keep moving.
Yep,
So, especially if it's hot outside. If you're down south in Texas,
that ain't gonna work.
back in the days, they used to sell cars for the Northeast and cars for the
Yeah.
South.
True.
Like the same car from Detroit, they'll have a different radiator for the car going New
And
England.
air conditioning too.
Yeah. And different radiators for the car sold in Texas. Because different temperature, it makes a big difference. And if you take the other class, probably you know that delta T make a difference.
They made it mandated in Arizona, the cars to be
Yeah.
air conditioned now.
Yeah,
Yeah.
makes sense. A motor, this is a electronically commutated motor, which means, we'll talk about that later, but it has electronic chip that control the speed and control the rotation. What is this?
It's like some kind of compressor.
No,
Fan bar?
no. First of all, it's red. Has to do with, huh? Yeah, it's a pump. It's a fire pump. Usually, most rail equipment are related with the fire system. So it's a pump. What's a pump? This is the pump part. And this is, does it look like that?
Yeah.
Yeah. So it's a motor connected to a pump. There's a coupling in the middle here. So this is the pump part, where the water connects from one side and goes to the other. And this is the motor that rotates the pump. So a pump, it's a the complete pump system has a motor in it and also has the pump side here. And you can see there are screws, so you can take the pump out, change the pump, or change the motor. Usually the pump doesn't go bad that quickly. Something must be wrong with the motor most of the time. If you open this box here, probably you'll find what?
Wire.
Wiring, and what else? It has a shower. Huh?
Resweat switch.
Yeah, and what else?
Fuses on the
You can find a fuse?
the coils.
No coils.
On the relays.
No relays. Something that looks like a battery.
No windings.
DC.
No. Capacitor. Excellent. You'll find a capacitor. So if your motor is not running, good job, very good. If the motor is not running, probably you've been listening to Bill. So you take out the box and you'll find a capacitor. So that's the first thing you check before you disassemble the whole motor. Check this box and make it outside and convenient with screws, so you take it out and you check those components. If there's a fuse, check the safety switch and check the capacitor. And what is this?
Compressor.
Yeah. What kind of compressor?
Standing up one.
Oil.
Okay. It has oil, but it has a special name.
Hermetic compressor.
Yes, hermetic compressor. Why is it hermetic? It's
Does it flow?
because it's sealed.
Oh.
If you open this up, it looks like a cylinder, but if you open it up, you'll find a motor and a small compressor. It's sealed for many reasons. They don't want you to tamper with it. They don't want any air to come into it, and also because it's compressing refrigerant, they don't want any sparks get into it. So these things you do not fix. And it is a stand-up compressor, and usually it has 3 supports with suspension too, because it's always vibrating. What is this?
Solenoid.
Yes. There you go. Solenoid. A pin goes up and goes down, and it's a coil. What about this thing?
Resistance heater.
Resistance heater. This is the worst way to heat a house. This is good for temporary or small or short-term heating.
Oh, no.
It's a huge heating element, and it consumes a lot of energy, but you'll see it sometimes. So you can put that in your ductwork and it will heat the entire house, yes, but it will be again very costly. It's very costly to run, but it's very cheap to install. So we'll get exposed to more and more components, and I would like to provoke your curiosity to look at items and see the similarity and be able to identify what they look like. You don't want to be in the job and look at something and, yeah, what the heck is this? You know, you will be able to identify a motor, or identify a capacitor, or solenoids, guys. So look for similarities. Look for what can help you identify a motor. Motor is always rotating, and again, they come in different shapes and colors. So you can see a small motor. There are motors that as big as a pencil eraser. They're very small. Have you ever played with those little airplanes with the remote control? If you look at the motor inside, it's so small and efficient. This is how small it gets. And there are motors that are as big as, I don't know, this door. There are some huge
They have
motors.
really small drones now, them really small drones.
Yeah.
They probably have-
So they come in different sizes. Some of them, not all motors look like cylindrical. Some of them are square. Especially in fans, you'll see a small square motor with the rotor in it. We'll spend the whole chapter talking about motors. So motors, they consume electrical energy to rotate a device. It consists of 2 parts with a coil in the middle. I'll bring a motor and talk about it. So this motor here, if you look inside, it has a coil. That's the stator part, because it stays in place. And there is the rotating part, which rotates. That's in the middle. So that's the stator part. You can see it has a coil and metallic rods, connections. And here we have our rotating part.
Like a big alternator.
It looks like it's the same thing. An alternator is a motor, but in the alternator you turn this part and you get electricity. So it's the same idea. Again, we'll talk plenty about the components inside, and we'll take one out and put it back again, and hopefully it will work. But if you think about it, it's not that involved. It looks involved now, but once you know all the components, you will know what makes a motor. And so this motor turns the burner on. And this is what does this look like? What does this look like? It's called a squirrel cage fan. The squirrel cage fan basically provides some kind of pressure differential, and it will suck air from the room wherever it is and pump it out. And if you look here, this is the shaft where the motor is connected, and the shaft in this state is connected with a coupling. What is a coupling? Small piece of plastic that will extend the rotation part to another part. So in your engine, again, the car engine, if you notice, there's a lot of rotating equipment in your engine. Your water pump, your oil pump, your compressor, your alternator, they're all connected to the same motor. So you're using the rotation to turn on the tires and all those little components. That's why you have what in your engine? You have a belt system. So you see one big pulley coming out of the motor, and probably sometimes one belt going through all those components for different belts. So either you have one belt going through all the components, turns them on, or each component will have its own belt. I think most new cars have only one or two belts top. But
Just like trucks, I think.
Yeah.
Like so.
because with trucks you don't want to have this, one belt in case it breaks, and if it breaks sometimes it will be a big problem. So what we're doing here is something similar. We're using the motor to turn two, in this case two things. One of them is the fan, and the other one is a pump. So the pump will connect here through a coupling, and it will turn on as well. So again, we'll find motors and compressors. If you open the hermetic compressor, you'll find a motor. You'll find a motor and a fan. You'll find a motor and a pump, and so on. So it's something really important to know how to diagnose what are the components. Motors are not cheap. They vary from price from $30 to $300 for residential. You can go up to $700, $800 for a motor. The price of the motor goes for many reasons. The horsepower, we talked about power, right? Is how much power does this motor generate. If you look at this thing, it has a sticker on it, and it says, I want to switch. It says 1/7 of a horsepower. So, the strength. It has the volts, it has the RPM. What is the RPM? Rotation per minute. And your car, what is RPM? Revolution. What is revolution? Complete cycle of the engine, where it takes in the gas, combustion, and take it out. That's a revolution. It's a revolution per minute. What else do we have? The hertz. What are hertz? Frequency. It has the amps. It has also, that's what you need. The phase, TH is phase. And some other things that we don't know what they are. This is GE old motor. I'm gonna pass it around so you can look at it, see the information. And again, we will do a whole review in motors and their types, what are the differences, because it's really important to know how to pick the right motor. Especially if you go with old designs and old boilers and the motor is no longer is there, what can you put in there instead of the old component?
Why are these wires black and these copper?
Probably the bird. That's why probably they use those administration. So this is one of the common. It's one of the common symbols for motor. CFM is condenser fan motor, evaporator fan motor, or compressor motor. Don't depend on this symbol to be the same everywhere. It's gonna be different. Sometimes they'll put a box and say motor. So you have to look at the legend and see what is the abbreviation. This also another symbol for a motor. And what do you think those steel line represent?
Coils?
The coils. You're on fire today, Lincoln. I like it. Awesome, man. Thank you. So, yeah.
See you.
Don't be jealous. Don't be a hater. So, coils, and this is a switch, centrifugal switch. But using common sense, we have coils. The motor has coils, so this is going to be the motor symbol for a motor. And probably it will be different from one industry to another. So let's get familiar with that. And again, if you read some schematics and you open it up, they have a legend that tell you this is what we go to abbreviate the motor, or this is the shape we're going to use for the motor. But
Solenoid's like a heartbeat.
yeah. Solenoids, again, devices that create a magnetic field when energized and cause some action of electrical component, either relay or valve. So if we can remember this little idea of a coil that makes a magnet and pulls things in and out, you understand what a relay looks like. And I have a few here that I've showed you before, and if you look, you'll find solenoids. These three are solenoids. This could be opening or closing a sensor. This is a relay, which when energized, it will pull those little arms and make a connection. There you go. Examine them. They consider to be a load. Why do you think they consider to be a load?
It consumes energy and power.
It does consume energy. This coil consumes energy. If you look at this coil over here, it's a big bundle of wire, probably at least like 300 feet wrapped around, and it's very thin, so probably it has high resistance. And in doing so, it's going to consume some power. So they do consume electricity, so they also loads. This is where you'll see. Everybody's done with this slide?
No, yeah.
I'll show you the resistance of this load. I'll bring my multimeter. Oh, you're right.
I still haven't gotten how to do that.
So if you want, can I borrow that little?
This one?
Yeah. I want to see what is the resistance. So how do I measure the resistance? I'll connect to the two loads. And what am I reading?
173.3.
173 ohms. So if this solenoid is 173 ohms, and I know my volt, this is the resistance. My voltage is 118 volts. How many amps is it going to consume?
Yeah, 65.
Six, the point, 68. So what is the power, guys? I'm gonna have you do stuff like that, so you better pay attention.
What?
I'm gonna have you do stuff like that, so you better pay attention.
See, I like to do
So-
stuff like that.
Where is the resistance? We measured the resistance to be 173 ohms. The voltage, you measured that from the power outlet, and I calculated the amperage. I want to know how much will it consume. So power equals amperage times voltage. You agree?
Yes.
0.68 times 180. I got 80. 80 watts. Is that a lot? It's not bad, but it's not nothing. What's an average light bulb power consumption? 60? 60 watts, 65. So you got 60 watts here. You understand this? If you don't, raise your hand.
You got that off the motor?
Huh?
You got it off the motor?
I get that out of the solenoid. Yeah, this one you have.
Oh, you read it?
I measured it with the multimeter.
Is that, oh, that's 6.68,
Yeah.
right?
So the little dot you see here is decimals. Do not ignore that. So 68 is not the same as 0.68. That's different. So make sure you pay attention to the decimals. Those are solenoids. They do make a difference. So this is a solenoid valve with a coil. So it could look like that, or it could look like a coil. So you'll see a solenoid valve over here, and its job is to turn on or off the circuit. I mean, check the water.
That's what I meant by heartbeat.
Yeah. AKG.
Yeah,
So that's a-
kg, yeah, exactly, you know?
Okay, so probably if you have a hot water system and you have some zones, what's happening? When the thermostat calls for heat, it will energize this solenoid over here. Guys, McCarthy.
You said that, turn on and off the water?
Yeah. So if you look here, there is a solenoid in here, but the thing you you're holding in your hand for.
Okay.
So this is solenoid. You energize it, it will pull up, it will be magnetized and pull the spin up. And this spin, this is the water flow here. It will open up the flow. So you can imagine what's inside? So this is what's going on inside here. This is my pipe. This is my pin. Once I energize the pin, it will come up, and the flow will go through.
Excuse me.
Here, guys.
Yeah, why you look at me so disgusted, bro? I can't bear it. Great.
Okay. So this is a solenoid valve, and it's also called a zoning valve. And probably if you work with any hydraulic system, you will have to deal with these. Some of them are 24 volts, some of them are 110 volts. Any questions about solenoids? This is only the beginning. We'll get exposed to them more often. Heaters. Heaters are, again, we talked about them before, small coils made out of sometimes tungsten carbide, another kind of material that has high resistance. You'll find them, basically you run current through them and they will start to heating cycle. Probably you find them in ice makers, in freezers, as a defrost cycle. So what do? They generate heat on location. So you turn that on and it will heat the coil, and the coil will melt the ice for defrost. Do you have electrical heaters in your car?
Or don't? I don't know. What?
Think.
Yeah.
I mean,
Yes.
bad idea.
The back sheet, the back window has heaters. See those wires? They'll heat up when you run current through them.
Got heated seats.
Heated seats. Now they have heated steering wheels.
Yeah, that's crazy. That's
They do have heated steering wheels.
Oh, those are nice.
It gets
It's
hot.
really cold.
Huh?
When it's really cold.
Yeah, it's really hard to touch the wheels sometimes.
They get hot too.
Yeah.
No, they get hot. That's crazy.
So probably heated seats.
Yeah.
You know what's really cool? Cool seats.
Yeah.
That's my thing, man.
Cadillacs.
Yeah, and Equinox, they have the cool seat. That's really the best invention of the century, in my opinion. But keep it cool, literally. Okay? What else? This is what they look like. They look like a resistance because
Yeah, can you go back real quick?
okay, so this is what I have for you for today, and I'll finish it up on tomorrow and Friday. Thank you, Pierre.